Yeah, good evening all. Now I am going to explain about some more questions on transformers. Now see here, if in a transformer PC is equals to core loss and PSC is equals to full load loss, or that means full load ohmic loss, that is nothing but copper loss, then the maximum kVA delivered to the load at maximum efficiency is equals to rated kVA multiplied by, that is kVA at maximum efficiency is equals to full load kVA into under root iron losses divided by copper losses. Here iron losses is represented by P suffix I, copper losses is represented by P suffix SC. That means here kVA into multiply with under root omega I by omega C, you write. That means from the given options, under root iron losses by copper losses, that is third option, 32nd one, third option is correct. Next, two transformers of the same type using the same grade of iron and conducting material are designed to work at same flux density and current density, but the linear dimensions of one are two times those two of the other in all respects. Okay, the ratio of kVA ratings of the two transformers closely equals to, okay, kVA rating is nothing but E1 I1, primary side is E1 I1, secondary side is E2 I2. Now see here, that is kVA rating. In case of transformer, input power is equals to output power. If we neglect the losses, that is kVA is equals to V1 I1 is equals to V2 I2, that is equals to E1 I1, that is equals to E2 I2, right? Already we know that current carrying element is directly proportional to area of cross section. Okay, from the EMF equation of a transformer also, induced EMF E is equals to 4.44 F into N1 into Bm into An. That means induced EMF is also depends upon area of cross section. Okay, from current equation, I2 by I1 is equals to A2 by A1. Okay, already we know that area is nothing but length into breadth. That means physical dimensions are doubled, means length is doubled, breadth is doubled. That means area is equals to 4 times of length into breadth, right? That is 2L into 2B. You will get 4 times of L into B, that is nothing but A1. That means I2 by I1 is equals to A2 by A1, that is equals to 4A1 by A1. A1 and A2 will be cancelled. I2 is equals to 4I1. Similarly, E2 is also directly proportional to area, right? That means E2 by E1 is equals to 4, that is E2 is equals to 4 into E1. That means KVA2 is equals to E2 I2 by E1 I1. E2 is nothing but 4E1, I2 is nothing but 4I1. That means KVA2 is equals to 6 times of KVA1 is the correct answer. Okay, now from the given options, option A is correct. Next, 34th question, a 3:1 transformer has impedance of 1 plus J5 ohm on the LV. That means see here 3:1, right? 3 is N1 turns, 1 is N2 turns. That means N1 turns are more means that is high voltage winding, N2 turns are less, that is low voltage winding. That means low voltage impedance is given as 1 plus J5 and HV impedance is given as 9 plus J5 ohm on the HV side, right? The total equivalent impedance at the HV terminals is, okay. Now see here from the given question, first what is given? K is nothing but transformation ratio, right? N1 is to N2 is nothing but 3:1 is given, but transformation ratio K is nothing but N2 by N1, that is 1 by 3, right? LV impedance is given as 1 plus J5, HV impedance is given as 9 plus J5. Okay, now what is given in the question? The equivalent impedance at the HV side terminals. The equivalent, see here Z equivalent is equals to, equivalent refer to HV side, right? HV means primary side. That means LV here, LV is secondary side. That means I need to transfer LV impedance to primary side, that is ZLV dash. Okay, that means that is ZHV plus ZLV divided by K square. That means ZLV is R2. That means R2 is transferred to primary side, right? That means that is R2 dash, right? That is R2 dash is equals to R2 by K square. The same concept is applicable here. That value K is nothing but 1 by 3 whole square. If I simplify this equation, I will get the answer as 18 plus 90 J ohm is the correct answer. Next, a 220 by 400 volts, 50 Hz, 5 kVA single phase transformer operates on 220 volts, 40 Hz supply with secondary winding open circuited. Then now see here what is given here. First case, assume 220 volts, 50 Hz from the given data. The rating 220 volts by 440 volts, 50 Hz, right? 5 kVA single phase transformer operates on 220 volts, 40 Hz. Frequency is reduced, but supply voltage is constant, right? From the given data, primary side assume 220 volts reference. Why? Because based upon the operating frequency at secondary side, that is 40 Hz, right? That means primary side is 220, 50 Hz. Here from the given data, the frequency is 220, 40 Hz. Frequency is reduced, but voltage is constant, right? That means V by F ratio is variable. Okay, now see here, in case of transformer, when V by F ratio is constant, okay, hysteresis losses is directly proportional to frequency, eddy current losses are directly proportional to frequency square. Okay, when V by F ratio is not equals to constant, from the given data that is not constant here, that means hysteresis losses are directly proportional to V whole power 1.6 divided by F power 0.6, and eddy current losses are directly proportional to voltage square. Okay, now see here from the given options, first both eddy current loss and hysteresis losses are decreased. That means see here 220 volts, 50 Hz. Here 220 volts, 40 Hz. Frequency is reduces from the given transformer. Okay, 220 volts by 440 volts, 50 Hz transformer operates at 220 volts, 40 Hz frequency, and it is operate with reduced frequency. When frequency is reduces, what happens? Hysteresis losses is depends upon frequency, right? Already we seen the equation. WH is directly proportional to V whole power 1.6 divided by F whole power 0.6, right? When frequency is reduces, hysteresis losses will be increases, but eddy current losses doesn't depends upon frequency. That means from the given options, see here both hysteresis and eddy current loss are decreases. That is not correct. Second option, both eddy current and hysteresis losses increases. That is also not correct. Next, third option, eddy current loss remains constant, right? Eddy current losses is directly proportional to voltage square. That means this is correct. And but hysteresis loss increases when frequency reduces, hysteresis loss increases, right? That means 35th question will be C is correct. Next, 36th. Yeah, next, the hysteresis and eddy current losses of a single phase transformer working on 200 volts, 50 Hz supply are P suffix H and P suffix E respectively. Okay, the percentage decrease in this when operated on a 140 volts, 50 Hz, right? First case, what is the voltage rating? 200 volts, 50 Hz. What is the V by F value here? V by F 200 by 50 is nothing but 4, right? Right, V by F here 200 by 50. Next case 160 volts, 40 Hz, right? That is also 4 only. That means here V by F ratio is constant. When V by F ratio is constant, hysteresis losses is directly proportional to frequency, and eddy current losses are directly proportional to supply frequency square. Then from this equation, omega H2 by omega H1, actually in the problem is mentioned phi suffix H. Phi suffix H is also indicated by hysteresis loss. Omega W suffix H also is represented by hysteresis loss. WH2 by WH1 is equals to F2 by F1. That is WH2 is equals to WH1 into supply frequency starting 50 Hz, right? F1 is 50, F2 is 40, right? That is 40 by 50. If I simplify that equation, WH2 is equals to 0.8 percentage of WH1. That means if I write in terms of percentage, that means WH2 is equals to 80 percentage of WH1. Okay, similarly eddy current losses, WET by WE1 is equals to F2 by F1 whole square. That is WE2 is equals to WE1 into 40 by 50 whole square. That is WE2 is equals to 0.64 times of WE1. That is WE2 is equals to 64 percentage of WE1. Okay, that means how much percentage is reducing in case of hysteresis loss? Suppose input is 100% losses, here WH2 is 80%. That means 20% reduces. Here approximately 36% is reduces. Right? From the given options, option B is correct. Next, For a single phase transformer, Re is the total equivalent resistance, Xe is the total equivalent leakage reactance, P suffix C indicates core loss, the load current at which maximum efficiency occurs. The load current at which maximum efficiency occurs. Okay, that means direct formula under root iron losses divided by copper losses. Okay, from that equation you will get 37th answer will be under root PC divided by RE. First one is the correct. Next, the maximum efficiency of a transformer occurs at 80% of full load. Its core losses is P suffix C and ohmic losses is P suffix OH. For the transformer, the ratio of PC by POH is dash. Now see here, the maximum efficiency of a transformer at what load? 80% of full load. That means assume efficiency, okay, maximum efficiency at X load is equals to under root iron losses divided by copper losses. Here iron losses are represented by P suffix C, copper losses are represented by P suffix OH. That means 0.8 is equals to under root PC by POH. See the solution. Okay, 0.8 is equals to under root Wi divided by WCU. Okay, that is Wi by WCU is equals to 0.8 can be written as 8 by 10 whole square, right? That is omega I by omega Cu is equals to 64 by 100. That means 0.64, right? From the given options, third answer is correct. Frequency of the supply voltage to a transformer at no load is increased, okay, but the supply voltage is held fixed with this. Okay, what is given? Frequency of the supply voltage to a transformer at no load is increases. Frequency is increases, okay, but the supply voltage is constant. That means V by F ratio is variable. When V by F ratio is variable, eddy current loss remains constant, right? But hysteresis losses is increases, right? Already we know that when V by F ratio is variable, hysteresis losses is directly proportional to V whole power 1.6 divided by F whole power 0.6. When frequency is increases, then hysteresis losses will be reduces, right? But eddy current losses are directly proportional to V square, right? That means eddy current losses are remains constant. First option is eddy current loss remains constant, correct, but hysteresis losses increases. That is not correct. Second option, eddy current loss remains constant but hysteresis loss decreases. When frequency increases, hysteresis loss is decreases, right? That means 39th question will be B is correct. Sorry, B is, that means second option is correct. Next, third option. Third option, magnetizing current increases but core loss current decreases. That is also not correct, right? Fourth option, both magnetizing and core loss current are decreases, right? When supply frequency increases, IMU, magnetizing component of current, and core loss component of currents are decreases. That means fourth also correct. Now see here, from the given options 2, 4 are correct. That means B is correct. Next, 40th question. The voltage applied to the primary is increases by keeping V by F ratio is constant. With this, the core loss will be. Already we know that when V by F ratio is constant, hysteresis losses are directly proportional to frequency and eddy current losses are directly proportional to frequency square, right? Now see the solution here. When V by F ratio constant, hysteresis losses are directly proportional to frequency and eddy current losses are directly proportional to frequency square, right? Now see here, that means when supply frequency reduces means voltage should be increases. Okay, now see here in this problem, hysteresis losses are increases. Okay. When V by F ratio constant means B maximum is also constant. B maximum is constant means from the BH curve, when B maximum is constant means the flux which is required, the current which is required to produce the flux is also constant, right? That means I mu or magnetizing component of current is also constant. Now see here from the given options, core loss. Core loss is nothing but here core losses are increases, but magnetizing component of current will be constant, right? From the given question 40th answer will be D is correct. Okay, remaining we will see next class. Okay, thank you all.